Welcome, folks. Today we are diving into three programming paradigms: procedural, object oriented, and functional programming. Throughout history, we have tackled problems with different approaches known as paradigms. These are like lenses for programming. Programming languages support these paradigms. Some, like Lisp, are all about functional, others, like C, are procedural. Simula, on the other hand, is all about object oriented. In this video, we'll explore the differences between these paradigms. Let's start with the basics. In procedural programming, we work with something called procedures or routines. Think of these as sets of step by step instructions for a computer to follow. It's like following a recipe when cooking your favorite meal. Now let's explore the key features. First up, we have scoping. Think of this as a set of rules that act like boundaries in your code. These rules keep everything organized, making sure you don't accidentally mess with parts of your code that you shouldn't. It's like playing a game with clear boundaries. Next, we've got modularity. This is all about breaking down your code into smaller, reusable pieces or modules. It's like building a complex structure with building blocks. This approach is super efficient and reduces repetition, just like using Lego bricks to create amazing structures. And finally, parameter passing. When you want to share information with your procedures, you have different options. It's a bit like sharing instructions with a friend. You can either tell them directly, which is known as passing by value, or you can give them a map, which is passing by reference. These key features are the building blocks of procedural programming. They make your code organized, efficient, and easy to work with. Now let's move on and explore the advantages of this programming style. Now let's explore the advantages of procedural programming. So what makes this programming style a great choice? Let's break it down. First on our list is simplicity and ease of implementation. Procedural programming is all about keeping things uncomplicated. It's user friendly, making it a piece of cake for computers to understand. If you are a beginner, even better, it's a smooth entry into the world of coding. And next, we've got modularization for reducing redundancy. Think of your code as a jigsaw puzzle. Procedural programming helps you break your code into pieces that fit together seamlessly. This not only makes your code efficient but also reduces the need to repeat yourself. It's like having a box of Lego bricks to build different things without starting from scratch each time. Now, let's talk about improved organization and conceptual structure. Imagine your concepts neatly sorted into modules. It's like having well organized drawers for your stuff. You can easily combine these modules to create new things. No more searching for hours to find that one piece of code. Everything's in its place. Last but not least, we have general purpose programming capabilities. Procedural programming is like a toolbox filled with a variety of useful tools. It's not limited to specific tasks. You can use it for a wide range of projects. Whether you are working on a small project or something massive, this approach has your back. Now, let's look at the flip side. While procedural programming has its advantages, it's not without its disadvantages. Let's dive into some of the challenges you might encounter. First up, we have data exposure and lack of control. In procedural programming, your data is like an open book. This means anyone can access and modify it. While this might sound convenient, it can sometimes lead to unintended changes and tricky to spot mistakes. It's a bit like leaving your personal diary out for everyone to read. Another challenge is the procedural approach obscure data mapping. With this style, the focus is more on the procedures, the steps you need to follow, rather than organizing your data. This can sometimes make it a bit challenging to map your concepts into code. It's like having all the ingredients for a meal but struggling to decide how to put them together to make a delicious dish. These disadvantages are worth considering, and especially when choosing the right programming style for your projects. But remember, no programming approach is perfect, and each has its pros and cons. So, understanding these drawbacks is essential for making informed decisions. In our next segment, we'll take a look at some programming languages that follow the procedural programming paradigm. Ready to get started with procedural programming? You can use languages like C, C++, Python, Dart, Swift, Algo, Ada, Rust, Bash, and PowerShell. They are like the tools in your coding toolbox. Now, let's move on to functional programming. In this paradigm, we're dealing with a special player, functions. Functions are the basic units of this style, and they are treated as first-class citizens of the language. What does that mean? Well, you can think of functions like super flexible tools in your coding toolbox. In functional programming, functions can be assigned to a variable. passed as an argument, or even returned from a function, just like regular variables. This concept removes the difference between functions and data, making it super versatile. It's like having a Swiss Army knife where each tool can be used in any context. Now, let's explore the core concepts and terminology that make functional programming unique. First, we have side effect. This term refers to the act of modifying non-local attributes inside a function. In simple terms, it's like making changes that affect things outside the function. Programming languages that allow side effects are known as impure functional languages. Next, we have immutability. In functional programming, once you assign a value to a variable, it stays the same throughout the program. It's like having a label on a jar that you can't change. Once it's labeled cookies, it will always contain cookies. Finally, we have functional composition. This is the act of applying functions to another function and chaining them together. It's like creating a sequence of actions. For example, you might apply function g to the result of function f, just like following a recipe that tells you to first chop the vegetables and then sort them. Let's dive deeper into the core concepts that make functional programming unique and powerful. Ad hoc polymorphism is a mechanism that allows a compiler or interpreter to distinguish which implementation of a function to use based on the types of arguments a function is called with. This is commonly known as overloading. It means a function may have multiple implementations for different parameter types or signatures. It's like having a versatile tool that can change its functions based on the job at hand. Subtyping is a way to define a relationship among types, creating subsets and supersets. For example, you can think of a cat and a dog as subtypes of the general type animal. It's like categorizing different types of fruits under the broader category of fruit. In functional programming, we treat functions just like any other variable. For instance, in such a language, a function can be passed as an argument to other functions, returned by another function, and even assigned as a value to a variable. It's like having the power to use functions as building blocks in your code. Higher order functions are functions that can take other functions as arguments or return functions as results. This is possible because in functional programming, functions and data are treated as the same thing. It's like having functions that can work together like cogs in a well-oiled machine. Recursion is a functional equivalent of iterative loops. It's a technique where a function calls itself until a base case is met. Most languages that follow functional programming principles optimize the performance overhead of recursion through techniques like tail call optimization or compiler optimization. This is akin to having a self-replicating robot that keeps working on a task until it's complete. A pure function is a function that returns a value and doesn't alter the state of non-local attributes. It's like a vending machine. You put in a coin, make a selection, and it gives you a snack without changing its internal state. Referential transparency is a mechanism that doesn't allow it to change the value of a variable once it's defined. This ensures that functional programs are referentially transparent. In simpler terms, if a is equal to b, then the function fa will always be equal to fv. This property of purely functional languages makes programs easier to understand and optimize. It's like having a strict rule that once you write something down, you can't change it. Now, let's explore the advantages of functional programming, and there are some compelling reasons to consider this approach. Functional programming makes programs easier to prove for correctness because functional programs don't change their states. This characteristic makes functional programs easier to model and reason about. It's like building a puzzle where each pieces fit perfectly without any surprises. Functional programming is ideal for both concurrent and parallel programming. In concurrent programming, multiple tasks are executed concurrently, while in parallel programming, multiple tasks are executed simultaneously. It's like having a synchronized dance where each dancer knows their moves, making the performance flawless. Compilers can easily optimize and substitute complex expressions into simpler ones in functional programming. Referential integrity gives the compiler more freedom to rearrange expressions, resulting in better optimization. It's like having a super smart assistant that organizes your tasks efficiently. Functional programming ensures programs are guaranteed to be secure and safe. Functions are independent of one another, reducing the risk of resource leaks and accidental modification of critical information. It's like having a vault where everything is locked up tight and only the right keys can access it. Functional programming allows you to express elegant programs. It's like creating a beautiful work of art with a simple, clean brushstroke. The code becomes a masterpiece of simplicity and elegance. But like everything, functional programming has its downsides. Let's take a look at the challenges. Immutability can be costly since every value requires a new space in memory. It's like getting a new notebook for every single note you write. This can lead to memory consumption. Compilers that don't optimize for recursion may incur insignificant performance overhead. It's like driving a car without a tuned engine, it might not run as smoothly as you'd like. Writing functional programs requires you to think mathematically. It imposes a mathematical model for programs that may not be the most convenient way of organizing concepts for some developers. In other words, it's not always easy to write functional programs and it's like solving complex mathematical equations. Let's take a quick look at some programming languages that embrace functional programming principles, including Lisp, Haskell, Scala, Julia, R, C++, Python, Java, C Sharp, and Swift. In the next section, we'll be talking about object-oriented programming. It is a powerful paradigm and it's built around some key concepts that we're about to explore. At the heart of OOP are objects, and these are not just lines of code but representations of real-world objects. An object has two main parts: attributes that describe its state and behavior that captures the actions it can perform. It's like creating a digital twin of something from the world. For instance, think of a car. In OOP, we can model a car as an object with attributes like its model name and current speed. But what really makes it interesting are the behaviors it can perform: starting, accelerating, and stopping. You can interact with these objects through their public attributes just like you'd interact with a real car. Now, let's dig into the principles that underpin object-oriented programming. These principles guide how we create and work with objects. Abstraction is like looking at a device with a simpler user interface. You don't need to know how it works internally. You just use the interface to get things done. In OOP, it means hiding the complex implementation details and exposing only what's necessary to the outside world. This way, the outside world interacts with an object through its interface. Encapsulation is all about building the code or methods and related fields or variables together as a single unit. It's like packaging something securely. In OOP, you can think of this as wrapping your code and data in a protective layer. It ensures that variables or fields can only be accessed or updated through getter or setter methods, and they can be hidden from other classes using private access modifiers. Inheritance is like passing down traits from one generation to next. In OOP, it refers to the concept where a subclass, also known as child class, inherits the properties and behaviors of another class, called the superclass. This is similar to how a BMW car inherits properties from a generic car, while the generic car inherits properties from a vehicle. It's a way of reusing and extending code. Polymorphism allows one name to take many forms, just like a chameleon, changing colors depending on its environment. In OOP, it means that the same object can behave differently based on the context. OOP offers two forms of polymorphism: runtime polymorphism and compile-time polymorphism. Runtime polymorphism is also called overriding. This allows a function to override a previous implementation of a method inside the superclass. It's like giving a new set of instructions to a task while keeping the same name. Talking about compile-time polymorphism, it is also called overloading. This allows a function to have multiple implementations based on the function's signature. It's like having different tools with the same name but used for different tasks. Now, let's talk about the advantages and disadvantages of object-oriented programming one at a time. OOP provides a direct and intuitive way to map real-world concepts and methods into code. This makes it easier to express and model complex problem domains. It's like creating a digital reflection of the real world. With the right design, OOP allows code bases to scale efficiently. The hierarchical structure of concepts is easy to impose, making it easier to add new features and functionalities. It's like building a modular structure that can grow as needed. OOP simplifies the interaction and communication between objects. Objects can send messages to each other, making it straightforward to represent relationships between entities. It's like having a conversation where each participant knows how to communicate. OOP promotes code reuse through the creation of reusable software components. This reduces redundancy in the codebase, making it more efficient and easier to maintain. It's like having a library of tools that you can use across multiple projects. Encapsulation in OOP allows data to be hidden from external access. This enhances resource safety and security, preventing unauthorized access or modification. It's like having a lock on a door to protect what's inside. Now, let's talk about disadvantages of object oriented programming. Implementing parallelizable programs in OOP may require additional effort. Managing interactions between objects can be complex, especially in concurrent scenarios. It's like juggling multiple tasks simultaneously, which demands more focus. Poor design in OOP can lead to an unnecessary level of indirection, resulting in code that's hard to read and understand. It's like following a convoluted path that takes you far from your destination. OOP often results in larger program sizes compared to procedural code. The extensive use of objects and hierarchies can lead to more substantial code bases. It's like building a complex architectural structure that occupies more space. Now, let's take a look at some of the languages that follow object oriented programming: Simula, Ruby, Python, Smalltalk, JavaScript, TypeScript, Dart, Java, C Sharp, and C++. In our journey through programming paradigms, we've explored procedural, object oriented, and functional programming along with languages that exemplify them. Remember, the choice of paradigm and language depends on your project needs. The magic of programming is your ability to shape the digital world. Happy coding!